Hey guys, how's it going? I'm Ethan, this is Carbra, and imagine uploading videos to your YouTube channel. Yes, I am back. It's been a while. I've had some personal shit going on, and I've been ill twice, literally, twice. So that sucks. But I'm back for this, just for this one video today. I've been trying to do a lot of recordings today, and none of them have been going amazingly well. But we're going to try and get this one video out because it's been so highly requested. If you're unfamiliar, I have a Discord server that you can join in the description below, and this is where the request came from because I was showing people how to do stuff with psutil, and they were like, oh, make a video, and it's been very highly requested for a month. As I said, personal stuff, illness. Actually put my thumbs up there as though you could see that, but we are actually doing it today. Holy shit. It's been too long. It's been a while. But we're gonna do it today. So psutil itself is a library in Python that allows you to get information about your computer itself or a specific process. Or in the case we're going to be using in the process that is actually running. So to actually install psutil on your computer, it's not that bad. You just need to open a CMD. Now I found out recently that that pip works differently depending on what you do with it. Now I knew that it worked differently. It knew you accessed it differently between Unix-based systems and Windows. So if you're on a Unix-based system, you do Python 3.8, or in my case 3.8 because I'm running 3.8. You would use whatever version of Python you want. Pip install, and then if you wanted to do upgrade, you could, but we're probably not going to bother doing that today. If you're on Windows, you use Pi to access Python stuff, but there are two different versions for Windows. If you did not install it for all users, it's pi-m pip to access it. If you did install it for all users, you just use pip. One easy way to check is if there is a folder in your program files called Python 3832 or 3864 or something like that. Essentially, if the Python folder is in your program files directory, then you just use pip. Another way to check is to just use pip and see if it works. So just type pip. If that comes up, it works. If it doesn't, you'll need to do pi-m pip. It's an interesting thought. Does it work? It works anyway, fair enough. So you might just want to use the second one regardless. We need to do pip. I'm just going to use pip install because I installed it for all users because I'm the only user on this computer. And we need to do psutil. I'm going to do an upgrade call just in case there's a new version of it out. But you don't need to do that. There we go. So I've upgraded to psutil 5.7 now. So we're going to be doing 5.7. That has literally come out in the last hour. I tried to do a video of this before, did this exact same call, and it didn't update. So I'm one of the first. Oh yes. But we're using Python, psutil 5.7. You might be using a slightly newer version of it. I doubt what we're doing it's going to be massively influential because we're just using kind of the more simple stuff. This is not going to be a comprehensive overview of psutil because there's a lot to it. So you can look in the docs online if you want. So we're going to install a few, we're going to import a few libraries to help out with stuff. So from datetime, whoops, it'll help if I could actually type, import datetime. From sys import argv, and from time import time. The date, time, and time is just going to help us with some formatting stuff. The sys argv I'll explain in a bit. And we're going to import psutil as psu. I would normally do a from import, but it's just going to be easier if I reference stuff with psu. And we're going to set a constant called name, and that is going to be argv0. So essentially what argv is sort of like a command line thing for it. So if I actually just type, if I type, and then the 0th element is the actual name of the script. So if I do like print argv and then print name, you see what I mean. So this is kind of like a list of command line stuff because we didn't pass any arguments through. When we ran it, it's just the 1, and of course if you get the 0th element, that we actually get the name of the file, which as you can see here is psutil tut.py. So that just makes it easier. You don't have to do that really, but it just makes it more scalable. It's just easy to use pretty much. So we are going to define 2 functions today. We're going to define system info, which is going to take nothing, and process info, which is also going to take nothing because we don't need to pass any arguments in, unless you potentially wanted to do like a process name or something here, but we're not going to bother doing that because we're just going to get the information for the process that is currently running. We'll start with the system info. I'm unsure about whether or not I want to type all this out. I did last time, it took a while, so we'll probably just copy and paste it in 1 line at a time, and I'll explain what we're doing. So I like to do this in a dictionary just so it's easier to do. So you have like a definition and a value almost. So if I just copy the first element of it in here, boop, boop. You see we have the uptime, and then the uptime is set to then this in the dictionary. So the uptime is basically the amount of time it has been since the system booted up. So this PSU boot time is a Unix timestamp of when the computer booted up, and of course time is a Unix timestamp of the current time. Subtract one from the other and you get the amount of time the computer's been up in seconds. If you put it through a time delta function, it just formats it a bit nicer. You don't necessarily have to do that, I just choose to. Next up we've got CPU in use, which I have set as well this. So you use PSU and then you use this, the CPU percent function, and then I put a little percent in the end, which is why it's all in a format string. Just I like my formatting, okay? This interval keyword argument is not technically necessary, but it sort of is necessary. It's what I'm going to call pseudo necessary. You don't need it, but you kind of do. The default for this is set to, I think the default for this is 0 anyway, I might be wrong about that. But if it is set to 0, it's basically useless the first time it gets called. It only starts doing stuff the second time it's ever called, which is a bit weird. But if you have an interval, I think the docs recommend 0.1, or at least when I looked at them they did. And if you have that, it makes it work pretty much. I'm not sure why that's a thing. That's beyond my knowledge base, but yeah, that's just the thing you need to do, so keep that in mind. You can set that to anything, but I think the higher you set it, the more accurate it is, but there's no point in setting it to more than 0.1 really. Third thing we're going to use is time on CPU, which is essentially the amount of time that the computer has spent processing stuff. So this is again going through a time delta function where the seconds, these are both timestamps as well. They're not Unix timestamps, I think they're just integers, but it's just easier. So we're using the CPU times function, which actually returns an object. So the .system is an attribute of that, and then .user is also an attribute of that. You also have .idle and .iowait, which do different things. Idle is how long the computer has spent not doing anything. iowait is how long the computer has spent waiting on I/O devices to free up. System and user, I don't know what the difference really is. I don't know when a computer would use its system clock versus its user clock. But it predominantly uses the user one in my experience. But we just add them together just so we can see how long it's used, how long it's actually been on the CPU itself. Next one is memory in use, which we use the virtual memory function for, and again this returns an object. Let's not do that. And we're just taking the percent and putting a percentage sign. That's fairly simple, to be honest. I don't think I need to explain that. This one here may look complicated at first, but trust me, I know what I'm doing. So this is the memory available. So you have, you don't really need anything beyond like this. Ignore this pink thing down here. So we're using the virtual memory function again, and we're using the available attribute because it returns an object. This stuff here is just formatting to go and get in gigabytes. That's an incredibly difficult word to say, and I hate it. But I want to be accurate on this channel. I would call it a gigabyte, but it's apparently not. Apparently is. That's a topic for another video at some point. about whether Microsoft or whatever, I think it's the IEEE, right, and whether or not this is a gigabyte or a gigabyte, whether you want to believe Microsoft or someone else, I don't know. But essentially this, what it's doing is it's dividing the available memory, which it returns in bytes, by 1024 to the power of 3. So if you did it by 2, it would be megabytes. If you did 1, it'd be kilobytes or kibibytes. And then we're using some string formatting here, which is defined by the colon. This is 1000 separator, so this basically says to put thousands in things. And this .3f is basically just say round to 3 decimal places, please, and it will do it. So that's grand. I don't know why I'm just about to type this in. I haven't been typing the rest of it out. You've got disk in use, which is very similar to memory in use, to be honest. So you've got this disk usage, and then the percentage, again, is just as an object, and the percent here. This is the directory. I've just done it for the root directory, so it basically says how much is on this disk. I think it's the root directory of the disk it's running on. So in this case, it's running on the D drive, which is my hard drive. So it's going to be a lot bigger. You can specify like specific directories. This one doesn't exist on my computer, but just as an example, so you can see if you build like a disk management software, for example, you can see like how much this particular directory is taking up of the disk. But because we're not worried about that right now. But you could potentially experiment with that if you so wished. Then you got disk free, which is using a disk usage function again. Has this free thing, a free attribute, has this free attribute, and then we're using the same system to get it down to gigabytes. And that's all we're going to work with today. There are many other things you can do, but that's basically the stuff I generally tend to use. Then we're going to print it all out. So all this stuff is basically just fancy formatting. This is the stuff you need. So for key and value and info.items. And then we're gonna print. No, we don't. We don't need to do that at all because we already have a print. We're gonna do system info, and then we're just gonna put process info here as well, even though it's not gonna do anything. Time delta is not defined. I've imported the wrong thing. Whoops. Yeah. We need to import time delta. Did I say time delta? I might have said time delta. But we need to import time delta in here, not date time. That was my mistake. So as you can see from this little snippet of the system info, the computer has been online for 5 days, 21 hours, 52 minutes, 31 seconds. Currently using 20.5% of CPU, which is this little function here, or this little readout here. Time on the CPU is 18 hours, 57 minutes, 44.7 seconds, so that's what it's been doing. Memory in use is this bit here. So it's how much RAM memory is in use, so it's 48.9%. Memory available is 8.1 gigs, more or less. Disk in use is 41.8%. Disk free, with just over half a terabyte left on my hard drive. So that's system info stuff. Process info stuff works somewhat differently, although we do have to do a bit more to get it to actually work. So the base thing is we need to iterate kind of every process, which is kind of annoying. We can't just like find one, as far as I know. If someone does know a better way to do this, let me know in the Discord. Plug for my Discord. I think I've already plugged it once. You can join in the description below and shout at me. Process we'll deal with the attributes right now. So while this is a perfectly valid thing you can do, it's not particularly efficient. So what you can do is kind of limit this function to only take what we actually want. In this case, it is this. So you pass it as either a list or a tuple, it doesn't matter which, of attributes, and I will explain what those do when we actually use them. Then we need to do a line which basically works out if the particular process we're looking at is the process we're actually running. So first we need to check, and I'm pretty sure all of these checks need to be done because I've tried it without some of these checks and it hasn't worked. So I don't know if I'm doing something wrong or if we do genuinely need to do all this. So if python in proc.info name. And no, don't ask me why this isn't pi on Windows. I'm fully aware I said before that you use pi for Windows on 3.8. It's still Python. I'm not sure why. Maybe it's just a fancy syntactical thing in a CMD, who knows. This process info.name essentially gets the name of the process, and the name of the process in this case, in this program, would be Python. And we're going to define something into CL using a Python 8's walrus operator. If you're not familiar with that, then I'm sure there are videos out there. Basically, it just means, so if I just complete this little thing for a while, there's something else I do need to explain before I continue much further as well. Essentially what this is doing is sort of like an inline variable assignment system. So what this will do is it will assign the value of procinfo command line to CL right here in this. You don't need the brackets around it. I just tend to put the brackets around it because I feel it makes it more readable. But this here is actually a perfectly valid thing you can do, but that's not particularly readable in my opinion. But that is, I really like the walrus operator. It's super damn useful. So whenever we reference CL, we're actually referencing proc.info.command line. Should explain what proc.info actually is. Proc is an object. It has an info thing, has an info attribute. I called it a thing again, which is a dictionary. And yeah, we're just referencing a dictionary basically. So this proc.info command line is pretty much argv, but for this specific process rather than, well, the process we're looking at rather than this process, pretty much. So we need to make sure that's not none, because that can be none apparently. Who'd have thunk it? We also need to check that len CL is greater than 0. So if the process is even using the command line at all, some of them don't. And if all of that's true, we need to check that if the name is in the final argument of CL. CL returns some weird stuff. I'm not entirely sure. I just know that the last argument is equivalent to argv, so the last argument returns everything. So basically, just if the name of the program is in the command line invocation somewhere, then do it. And we're going to have info again, and we're going to have the same process where we copy and paste a load of stuff. So the PID, because this takes a long time to do. I don't think this video would be that long. It's just a lot of explaining and a lot of typing with this. So the PID is the process ID. Fairly self-explanatory. Every process has a process ID. The uptime is basically the same as the one for the system. CPU in use is pretty much, I think it's almost exactly the same. Oh yeah, CPU, yeah. Except we don't need to specify an interval for some reason, I don't know why. Or mainly because it's not a function, I suppose. Time on the CPU is pretty much the same as well. I think we're actually using pretty much the same line. Well, more or less the same line. You may notice that most of these things in the proc info are the same as they are here. That's pretty much a standard. I think some of them are slightly different. So some of the ones that return objects aren't done like this, but they kind of are actually sometimes. Okay, maybe I don't know what I'm talking about. Yeah, there's more or less the same again. The number of threads is kind of just the number of threads. Really, there's not too much to explain about that. You can also get this little ordinal character from the character map. I just like it because it denotes number. Normal Python programs use 4 threads. Discord bots and stuff use 5, I think. Anything up to about 7, mostly. From what I've heard, but that's using the non-auto sharded client, so I don't know. We'll see. And then you've got your memory in use, which I'll actually explain properly because this one's quite different. So again, we're using this walrus operator to put whatever our proc info memory percent is into a variable called mem, and then we are simply rounding it to 3 decimal places because this gets rounded to 6, I think, by default. And then we have a percent here, and then this is arguably the most complicated line of the whole thing, which is memory usage, just because there isn't a memory usage attribute built into this. So use your psu.virtualMemory from up here, and we get the total amount of memory that the computer has, and then we multiply that by the memory times 100. and that gives us the amount in bytes it is using, or the memory divided by 100. Sorry. So basically, so this is sort of like a percent almost, and then, well, this is a percent. This essentially gives us like a percent, and then it does it like that, and then we multiply it by all this numbers we use up here to get in gigabytes, and that's just basically the same thing. I'm pretty sure that works, and then we have the same print statement from below here to print that all out. On this computer, the process info can take quite a while if you're running a lot of processes. On servers, it's pretty much instantaneous. So as you can see, as well as our system info from here, our psutil tot.py was given the process ID of 18,020. It was running for 1.16 seconds. It used basically none of the CPU. It was on the CPU clock for 1.03 of that time. It used 4 threads in total. It used 0.089% of our 16 gigs of RAM, and well, as you can see, it used 140 megs. No, it didn't. It used 14. I got that wrong last time as well. Apparently, I just can't read numbers. just can't multiply by 1,000. You know. Well, you could expect me to just multiply by 1,000. Are you serious? Yeah, he used 14 megs of RAM, so it was a pretty lightweight program. So that's basically how psutil works, really. A lot of people in the Discord server that requested this are there because of Discord bots, because of my Discord bot series, and they would imagine want to know how it would sort of work in a Discord bot, how it would translate. So this is something from a fairly old, but this bot is still in use, but it's being rebuilt currently. So I don't feel too bad about displaying this code. But as you can see, I'm using sort of the same sort of system, creating a table using a code block. Yes, I know it's a code block. Shut up about embeds. I don't want a single embed mention. Not one. Not one. As you can see, oof, that line's a big oof. As you can see, it's using roughly the same system. It's using the slightly worse version of it, because it's doing it in bytes, and it's also doing this on 2 lines and stuff. But if you go to our Discord server real quick, or Discord server down here, where this bot is actually running, we can see that sysinfo takes, there you go, so you have our system information taken at this time, and it's printing out, I think, the same stuff, yeah. And if you have our proc info, and then does that as well, so it then tells you the time on CPU. For example, this bot has been running for 26 days and it's been on the CPU for 8 minutes of that. It's a Discord bot. This VPS has been up for 324 days. What the fuck was that? I think a car just exploded outside. And it's been on the CPU for 3 days of that. And you can see how much memory is in use, and you can see how much memory the bot is using specifically, and all that fancy stuff. So yeah, that's how psutil works. Sorry this video was really late. Again, I explained all the stuff at the start. Hopefully the twitch.py series will come out fairly soon. Maybe in a week or 2, we'll see. But yeah, if you like the video, say hello down below. If you have any questions, go to the same place. Or if you want, which will probably be preferable, I have a Discord server which you can find in the description below, which I mentioned 3 times now. You can ask any of us any questions you want, and you'll get answers if we know them. If we have answers, we'll tell you. If we don't, then sorry. But yeah, hopefully I'll see you soon for the Twitch bot series. So if you're interested in that, then make sure to subscribe, hit the bell so you know about that. And I'm going to go now. So bye.